Learning objective 4 is to differentiate between monatomic and polyatomic ions. Mono. I'm going to do a lot of prefixes and suffixes in root words, and it's going to be so much fun. I hope you know these. Mono means one, poly, many. So a monatomic ion is a single atom ion. These are found on the periodic table. So most of the main block has set charges, not all of it, but some of it. So a monatomic ion is a single atom, so one atom with a charge. These are considered your ions of elements. All right, so let's look at the charges for these guys. So again, group 1, 1, group 2, plus 2, 3 through 12, they transition, so we kind of have to signify their charge. A couple of elements that are within the transition metals that do not actually transition. Arsenic always has a plus 2 charge, and silver always has a plus 1 charge. It's only those two elements. Everything else can transition between different charges, or what we call oxidation states. Metals will always be cations. Nonmetals are always anions. Metals, the name doesn't change. So the metal likes to keep his name. He likes his name. The nonmetals change the suffix of their name to IDE. Okay, so examples of these guys. You have Cu, 2+. Now, copper's in that middle part. It transitions between oxidation states. So we signify the charge of 2 as a Roman numeral. So this would be copper 2. A little bit more on that a little later, but we signify its charge by Roman numeral. Calcium 2+. So calcium is not a transition metal, so it's just calcium. Of course, these guys would have ions behind them. They would say ion. We can have a negative, so chlorine, so Cl -1. This would be the chloride. And then we also have oxygen, which is O2-, which would be oxide. Okay, so then we have polyatomic ions. So polyatomic, as their name suggests, these guys contain 2 or more elements. Covalently bonded. With an overall charge. These are found on the back of the periodic table. So these are mainly anions with only one as a cation. Okay, so you only have one cation. These guys, the names do not change. So they do not change. You do have to memorize some of these. You'll have a quiz over them, a pop quiz at some point. So these are the ones that you have to memorize. So again, to go through these: acetate, ammonium, carbonate, chlorate, chlorite, cyanide, bicarbonate, hydroxide, hypochlorite, nitrate, nitrite, perchlorate, phosphate, phosphite, sulfate, and sulfite. You need to memorize the names, the formulas, and their respective charges. um, that are attached to them. So these guys are the polyatomic ions. Okay. Now, you'll always have this on your thing. The reason that I'm making you memorize these is because it makes naming and formula writing so much easier if you have them memorized. If you don't have them memorized, it's going to be a lot harder because you're going to be looking for something and you're like, I don't know where this is. Where is this at? Where is this at? And I mean, it just makes it a little bit easier. So, examples of these guys. So I have phosphate. So PO4 3 minus. I have ammonium, which is NH4. It's the only positive ion for polyatomic. I have peroxide, which is O2, 2 minus. And I also have cyanide. So both are types of ions that form ionic compounds. That's how they're similar. So they both come together to form an ionic compound. So that is learning objective 4, which is to differentiate between monatomic and polyatomic ions.